This is a review of the topics from this week. We have speed and density, averages from frequency tables, scatter graphs, and plans and elevations. Starting with compound measures, this is speed and density. They're compound measures because they're made up of other measures. So speed is made up of distance and time. Speed is distance divided by time. And density is the mass divided by volume. Let's look at these examples. A cyclist travels 25 kilometers, so that's a distance, in 45 minutes, that's a time. Find the speed of the cyclist in kilometers per hour. So that means kilometers divided by hours. Our time has been given in minutes, so we need to convert that. So we're going to do the distance in kilometers, so 25 divided by the time in hours. 45 minutes is how much of an hour? It's 3/4 of an hour. Every 15 minutes is 1/4 of an hour. So we can write 3/4 or 0.75. And if we're doing this without a calculator, we'll double the top and the bottom. So 50 over 1.5. Double again, 100 over 3. And 100 over 3 is 33.3 recurring. So it's 33.3 recurring kilometers per hour. If we were doing this with a calculator, we could have used the time button on the calculator. So 25 divided by 45 minutes is 0 hours and 45 minutes. And again, that gets us the same answer of 33.3 kilometers per hour. The second question is a density question. Silver has a density of 10.5 grams per centimeter cubed. Find the mass of 80 centimeters cubed of silver. So we're finding the mass, we're given the density. So density is mass over volume. We're told density is 10.5 and the volume is 80. So how do we get the mass by itself? We multiply both sides by 80. So it's going to be 80 times 10.5. Again, we could use a calculator, but if we're not using a calculator, 10 80s are 800. Half an 80 is 40. So that means we've got 840, and it's a mass, and it's in grams. The density was given in grams per centimeter cube. So the mass is in grams. Okay, 2 of these for you to try. So give these a go. The first question, a piece of metal has a mass of 39 grams and a volume of 5 centimeters cubed. Find the density. So density is mass over volume. So in this case, 39 over 5. And 39 over 5, if we double the top and double the bottom, is 78 over 10, which is 7.8. So 7.8 grams per centimeter cubed. We had mass in grams, volume in centimeters cubed, so it's grams per centimeter cubed. And the second one, a car travels 60 miles, that's the distance, an average speed of 48 miles an hour, that's the speed. How long does the journey take? So speed is distance over time. We're finding the time. So we've got 48 equals 60 over the time. So we need to get t by itself. We can multiply both sides by t, which will give us 48t equals 60. And then divide both sides by 48. So t will be 60 over 48. So we could type this into the calculator, or we could try and simplify it without using a calculator. So half the top and the bottom, half again, and then divide by 3. So we've got 5 over 4. So that's 5 over 4 is 1 1/4, or 1.25. And that is in hours, 1 1/4 hours. So we could write that as 1 hour and 15 minutes. And if we did use the calculator, we could use the time button again. So 60 over 48 is 5 over 4, but press the time button and it will convert it to 1 hour and 15 minutes. Averages from frequency tables. This is a different way of displaying the information. So we've got information about the goals scored per game by a football team. We can read this table as no goals have been scored 8 times. So there are 8 zeros. 1 goal has been scored 14 times. So there are 14 ones. 2 goals have been scored 5 times, 5 twos, and 3 goals 2 times, so 2 threes. So if the numbers were displayed as a list, we'll have this. So what is the mode? What's the most common number of goals scored? That is 1. There are 14 ones. The median is the middle number. So how many numbers are there in total? 8 plus 14 is 22. Plus 5 is 27. Plus 2 is 29. So the middle number is going to be the 15th one. So where's the 15th number? Well, there's 8 zeros and then 14 ones. So the 15th number must be in the ones. So the median is 1. And the mean, so to find the mean, we're going to add them all up and divide by how many there are. So we've got 8 zeros, which is 0. 14 ones, which makes 14. 5 twos, which is 10. And 2 threes, which is 6. So we've got 0 plus 14 plus 10 plus 6, which is 30. So 30 goals in 29 games. We added up this before. So 30 goals in 29 games. So what is the mean? So if we do 30 divided by 29 to 1 decimal place, we've got 1.0. 1.0. And in this example, we have grouped data. So this is the heights of some plants. There are 5 plants with a height between 0 and 20 centimeters. We don't know the exact heights of the plants. We just know that these 5 plants are in the range from 0 to 20. There are 16 between 20 and 30, 18 between 30 and 40 centimeters, and 1 between 40 and 50 centimeters. So we're asked, what's the modal class, the most common class, the most common group? So that is the 30 to 40 centimeters group. There's 18 in there. So we just copy down this. So 30 to 40. Write down the class interval that contains the median. So there are 40 plants. The frequency adds up to 40. The median is the middle number. So that would be Well, we could split 20 on both sides. So we'll be looking at the 20th and the 21st plants if they were lined up in order. And the 20th and 21st plant are both in the 20 to 30 group, because 5 and 16 makes 21. So the 21st plant is in the 20 to 30 group, well, the 6th, 7th, 8th, 9th, 10th, 11th, 12th, all the way up to 21st are in the 20 to 30 group. So the median must be in the 20 to 30 group. And an estimate for the mean height. So the reason this is an estimate is because we don't know the actual heights of the plants. We have to guess. We have to use an approximation. And we do this by using the midpoint. So we're going to say all 5 of these plants are 10 centimeters tall, halfway between 0 and 20. All 16 of these we're going to say is 25 centimeters tall. All 18 of these plants we're going to say are 35 centimeters tall. And we're going to say that this plant is 45 centimeters tall. So now we're going to add them all up and divide by how many. So we've got 5 10s, which makes 50. We've got 16 25s, so we can use a calculator for this. 18 35s, which is 630, and 1 45. So let's add them all up. So we've got 50 plus 400 plus 630 plus 45. So it adds up to 1,125. That's the total height of all the plants added together. And we're going to divide by how many? And there are 40. The total frequency is 40. There are 40 plants. So divide by 40. And that's 28.125 centimeters. So does that make sense? 28.125. That's at the end of the 20 to 30 group. So that seems to be a sensible mean height. And here we have a scatter graph question. We've got a scatter graph showing maths test scores and the number of hours students spent watching TV on the day before the test. So there's 12 crosses here. Each cross represents one of the students. So this student here spent 6.5 hours watching TV and scored 48 on the test. So each cross is a different student, and we can use a scatter graph to look at the correlation, to look at the relationship between two things. So what type of correlation do we have? So if we have a correlation, if we have a scatter graph that as one goes up, the other one goes up, we call that a positive correlation. But in this case, as one goes up, the other one goes down. So that's a negative correlation. So this is a negative correlation. Another student spent 5 hours watching TV. Estimate their score. So to estimate a score, we need to first draw a line of best fit. So a line of best fit is a line that best fits, best represents the relationship. So it's going to be a straight line that goes through the points with roughly the same number of points on both sides. So I've got 4 points on both sides, and the rest of them are pretty much on the line. And I've minimized the distances as much as possible from all of the points to the line. So this is my line of best fit. You could draw a slightly different line of best fit and it will still be correct as long as it fits the relationship, as long as it shows the relationship between our two things, our two variables. So this student spent 5 hours watching TV. So to estimate their score, we're going to go from 5 hours up to the line, and then go across, and we'll read off what we get. So it looks like that's 50, and each one of these is 2. So 57 marks, 57%, just 57. So that is our estimate for their score. And finally, plans and elevations. Question 1. We have a solid shape drawn for us, and we need to draw on the centimeter grid the front elevation, so the view looking at it from the front, and the plan, so the top down view, the bird's eye view of the shape of the prism. So what does it look like from the front? It's got 5 centimeters along the bottom. It's 3 centimeters tall, and it's got, well, 3 centimeters along the top. So we've got a trapezium. Goes 3 centimeters tall and 3 centimeters along the top. So this is our view from the front. How about the plan? So the top down view. So we can see we've got 5 centimeters by 4 centimeters. Our shape is 5 by 4 in total. And we've got different heights. So we've got a 3 by 3 centimeter square, and then 2 slanted bits going down. So this is our plan. This is our view from the top. And this is our front elevation, the view from the front. And question 2. This time we've been given the front elevation, the view from the front, the plan, so the bird's eye view, the view from the sky, and the side elevation, and we need to sketch the shape. So what does this shape look like? So we've got an upside down T shape. As our front elevation, and it goes back 4 centimeters. So it goes back 4 centimeters. So let's just try and draw this shape. And we'll draw on the measurements. So we have 3 centimeters along the bottom, then 1 centimeter up, then 1 centimeter in, and then 2 centimeters up, 1 centimeter at the top, and 2 centimeters, 1 centimeter, 1 centimeter. So that's all of the front shape. And then I'll just write 4 centimeters going back. So that is our sketch. It doesn't have to be accurate. It's just a sketch of the solid shape. So if we looked at it, I should probably have another line here. So if we looked at it from the front, we can see this T shape. From the sky, we can see 3 along the front, 4 along, 4 going back, and these lines to represent the different heights. And from the side, we can see 1 centimeter by 4 at one height closer to us are then 2 by 4 at a different height. So 3 centimeters tall, 4 along, and a ledge at a different height. So that was our review. There is an assessment now available. The link will be in the description or at the bottom of the page on the website. So give that a go.